So the next one is exercise 43. Here we have a graph which has a name. It's called Newton's serpentine. You can see why, because it looks like a snake. And it is the graph of this function. Note that regardless of what x is, x squared plus 1 is never equal to 0. So this is defined on the entire real line. What we have to do is we have to find the tangents to this curve at the origin here and at the point 1, 2, which happens to be this peak. So you can clearly see geometrically the tangent at the origin will be a line like this, and here the tangent should be horizontal. So let's find these things. First of all, we have to find the slopes of the tangents at these points by differentiating the function. In fact, that's why we have it here. We have to differentiate after all. We have dy dx equal to d dx of 4x divided by x squared plus 1. So obviously we will have to use the quotient rule. The denominator will thus be the square of x squared plus 1, then the numerator will be x squared plus 1 times the derivative of 4x minus 4x times the derivative of x squared plus 1. Derivative of 4x is 4. Minus 4x times derivative of x square is 2x and derivative of 1 is 0. That means 2x divided by this. So this becomes 4x squared plus 4 minus 8x squared over this. That means 4 minus 4x squared divided by this. Okay, so that's the slope of the curve, or the slope of the tangent to the curve at any point x comma y. So at the origin, the slope will be, if you want you can write like this, but because we have already written at that point, so there is no need. So what will you get if you substitute x equal to 0? The denominator becomes 1, so it's gone. This term vanishes, that means the slope is 4. So the tangent to the curve at the origin has slope 4, and it passes through the origin, so its equation will be y equal to 4x. Okay. Next we have to find the tangent at the point 1, 2. At 1, 2, What is the derivative? We will get that by substituting x equal to 1 this time. Note that the numerator becomes 4 minus 4, which is 0, and the denominator becomes something. Okay, we do not even have to know what, because it ultimately becomes 0. And that's what we guessed, that the tangent at this point should be horizontal. Yes, it is, because the slope is 0. So the tangent to the curve at the point 1, 2 is, so if the line has to be horizontal and it has to pass through 1, 2, then its equation is y equal to 2. Okay, so these are the two tangents. Next, 44. Find the tangent to this curve, also like that one, has a name. Which of Agnesi? We will see in section 9.4 why this name is given. And the curve is just this: 8 divided by x square plus 4. At the point 2, 1. Well, let's also see how that curve looks, since it's given in the text and it's not very difficult to draw. Its shape is just like this, roughly like this. It has a peak at the origin and then it goes down again. And this point is 2. This point on the y-axis is 2. We, however, have to find the tangent at 1, 2. Here, somewhere. Here. No, sorry, 2, 1. Yeah, how can it be 1, 2? Oh, so that means, okay. So I have it wrong here. Of course, it's not wrong in the text, but I took it down wrongly. 2, 1, because this is coming down. So the level 2 is here. Since it has already come down, how can it be 1, 2? Alright. So let's find the tangent here as well. So the tangent will be a line somewhat like this. Eight divided by x square plus 4. Again we will use the quotient rule. This term is going to vanish because here we are multiplying by the derivative of 8 and this is 0. So this is, let me write one more line actually. No need to skip steps. X square plus 4 times 0 minus 8 times, differentiating this we get 2x and this one gives us 0. So 8 times 2x divided by this. So minus 16x divided by x square plus 4 whole square. Okay. So now the point is 2 comma 1 at 2 comma 1, what is the slope? So we have to substitute 2 for x. That means minus 16 times 2 divided by 2 square plus 4 whole square. So what does that become? 4 plus 4 is 8. That means minus 16 times 2 divided by 8 times 8. So if you take 1, 2 from this 8 and combine that with this 8, then you get 16. That means 16 times 4 in the denominator. So after cancelling 16, you get minus 2 divided by 4, which is minus 1 divided by 2. Okay. So this is the slope. Minus 1, you can see that it's minus because the line here will be like this. Negative slope. And why negative slope? Because the line makes an angle with the positive x-axis that's greater than 90 degree. That's why negative slope. Alright. So the tangent to the curve at 2 comma 1 is this. Just write the point slope form. You know the coordinates of the point and you also know the slope. So y minus y coordinate is equal to the slope times x minus x coordinate. So basically that's the tangent. You can rearrange terms and bring it to a more appealing form. I am not doing that. Okay, so this is the tangent. Instead, let's see the next one. The curve y equals ax square plus bx plus c passes through the point 1 comma 2 and is tangent to the line y equal to x at the origin. This sounds a little strange. The curve is tangent to the line. Well, tangent means line, but sometimes to express this fact that the line is the tangent to the curve, we also sometimes say that the curve is a tangent to the line. It just simply means what you already know. Okay, so with this information, find A, B and C. Okay, so we are given a pretty general curve because we don't really know what A, B and C are. There are some constants. In fact, we have to find their values. What is given that this curve is tangent to this line y equal to x at the origin, which means in particular that the curve passes through the origin. Otherwise, how can it be tangent to this line at the origin? Because there both the line as well as the curve has to meet. From that we will get something. The fact, namely the fact that the curve passes through the origin. Since the curve passes through the origin, so the point 0, 0 satisfies the equation of the curve. That is, its coordinates satisfy the equation of the curve. Y equals ax square, that means a times 0 square, y is also 0, x is also 0, plus b times 0 plus c, or c is equal to 0. So just from the fact that the curve passes through the origin, we have found c. It has to be 0. So with this new information, the curve becomes y equal to ax square plus bx. Alright, so now we are going to use the fact that this line is a tangent to this curve at the origin. So let's find the slope. Differentiating this, we get 2ax plus b, keeping in mind that a is some real number after all. A is not changing, a is constant. So at the origin, the slope will be obtained by substituting 0 for x, and that gives us b. Since y is equal to x is the tangent to the curve at the origin, so the slope of this line should be equal to that slope. But what is the slope of this line? 1, the coefficient of x, when you express the equation in this form, where you have y on one side and everything else on the other side. So that is why b should be equal to 1. Okay, so we have found b as well. Hence, the curve is y equal to We still don't know a, so it is ax square plus, but we know b is 1, so it's this. All right. Oh, I think, hold on. I think I forgot to completely write the question. Otherwise, yeah, how can we find A? Sorry for this. I missed one point. The point is that it's given that not only that the curve is tangent to y equal to x at the origin, but it is also given that the curve passes through another point. Yeah, that's what I was thinking. Something is missing. 1, comma 2. Sorry for this omission. So using this now, we will be able to find A. Because of this, we also have 2 equal to A times 1 square plus 1. That is A plus 1, or A equal to 1. Yeah, now it's okay. Hence, A and B are both equal to 1 and C is equal to 0. So that's the solution. There is one more exercise of this type, 46. Here, instead of a curve and a line, two curves are given. The curves y equal to x square plus ax plus b and y equal to cx minus x square. Like the previous one also, here a, b and c are unknown and we have to find their values. Have a common tangent. Common tangent line at the origin, I think. No, not at the origin, at the point 1, 0. With just this much, we have to find A, B and C. Okay, so now the point where both the curves have a tangent is given. The tangent, however, is not given, and we don't actually need that as well. The slopes, let me put it this way, the slopes of the given curves at any point x, y are m1. So I am calling m1 the slope of the first curve at any point. X square plus ax plus b. So when you differentiate, you get 2x plus a, and the slope of the other curve at any point is d dx of cx minus x square, which is c minus 2x. Since the curves have a common tangent, at 1, 0, these two slopes are equal because these are the slopes of the tangents I should perhaps say, to both the curves at that point. But it's given that there is only one tangent, so the slopes have to be equal at this point. At this point. That is, so what's the value of m1 at the point 1, 0? 1, 0 means x is 1. So if you put this, x equal to 1 here, you get 2 plus a. What do you get from here when you put x equal to 1? C minus 2. Okay, so we have got a relation between A and C. All right. But we also know something else, no? Namely, that this is a point on both the curves. That also we can use, and we have to use. Because simply from the fact that there is a common tangent at a single point, we get just this. From this we cannot say anything definitively. Also, 1, 0 lies on both the curves. So, if you put 1, 0 in the equation of the first curve, that is y equal to this, x square plus ax plus b, then what do you get? Y is 0, that is equal to a times 1 square plus, not a times 1 square, 1 square plus a times 1 plus b, or if you simplify, you get 0 equal to 1 plus a plus b. And then if you put 1, 0 in the second curve equation, which is y equal to cx minus x square, then you get 0 equal to c times 1 minus 1 square, or c is equal to 1. Because what do you get from here? 0 equal to c minus 1. So c has to be equal to 1. So we have found one of the three numbers, c. All right. We have found c, and we have also obtained two linear equations involving a and b. So we can now find a and b as well. Oh, no, not two linear equations involving A and B. This one involves A and B and this one involves O. So it's much better actually. You can directly substitute the C value here. Thus, what is A from this equation? A is C minus 4. But C is 1. So this is minus 3. Now that you know A, you can find B as well. And so, from this equation, what is B? In terms of A, B is minus A minus 1. A is minus 3, so minus A is 3. So this is equal to 2. Hence, A is minus 3, B is 2, and C is 1. Okay, so we have found the three numbers, minus 3, 2 and 1. Yes. So let's just keep this video till this itself. After these exercises, there are some exercises which need a computer grapher, a graphing facility. So I am going to leave those things to you. And in the next calculus video, we are going to look at the ones which come after them, after these graphing exercises, which involve physical applications of the notion of derivatives. So there we will see some things from physics, chemistry, things like that. Okay, so that's just it for tonight. And tomorrow we have our usual linear algebra upload. So see you tomorrow with this. Until then, this is me, Lucifer from A Mathematical Room. Have a nice night.